smart manufacturing. And the good thing is, I'll be talking about actual use cases. So these are actually working now in our factory. So these are not theories or concepts, but they're actually deployed now in our factory. So, our approach has been simple. How do we create the smart manufacturing journey for us? Basically, on the high level, we connect the machines to our backbone. We connect the factories to our backbone as well. We integrate those systems to ensure that they are talking to each other. At the same time, we develop and deploy applications, especially those are related to quality. And lastly, since we are collecting data from all the machines and factories, we use this data to be able to create those analytics, or what we call intelligence of our factory. Now I'll be going over one by one in terms of connect and integrate. So we have 6,000 machines and we connect them to our backbone. We use the connectivity protocol, 56Gen. These are enabled in the machines to be able to provide some capability for commands and control. Now what we build is, we build a computer integrated manufacturing, or SIM. Our machines are connected to a centralized server. We collect data. We have an automated recipe management or download for the machine parameters. We log all the events every second, everything that is happening to the machine. We even have the stop function if there are problems. At the same time, we check or validate the right materials are used, the right toolings. At the same time, the right parameters are used. So we validate that real time. Okay? Now, once we collect data, we use those data to drive analytics. Be able to understand what are the downtimes of the equipment, what are the defects. This is real time. Okay? Now, in terms of recipe management, so we develop a system wherein our engineers create a recipe for administration, and we put them to a production server. This way, the server could be able to do some upload or download within our equipment. So this is human-less touch or human-less effort. Okay, so that we are downloading the right recipe to the equipment. This is fully automated. We also have fault detection control, or FDC, to be able to control the parameters, as well as those alarm control. Now what we do here is that we have the control range setting being set by our engineers, and through surveillance, we can be able to notify the people in the line. We can be able to stop it, and we can be able to hold it. Do not process it if there's something wrong. And take note, 6,000 machines, these are fully automated. So we connect all the machines through wireless or wired, and all of these are connected to our backbone. We monitor them, so we can be able to see if they are running, they are not running, they are red, or they are waiting for something. So with that, we have a real-time visualization by line, by floor, by building, by factory. And since we collect data, we can be able to collect the downtime, the troubles, what's going on, why is it not running, and we provide analytics. This is an interactive visualization for our engineers to use it to go at least 6 levels of analysis. No need for Excel sheet. No need for manual downloads, okay? Now, let me show you this one. So in terms of handling, material handling, the movement of products going to different machines, different process, we have this automated guided vehicle system. This is for Amcor. We have built this AGV for us to transport those products. We have built in a lot of sensors. So it's transferred from machine to machine, and even provide some transportation going to a specific location. So with this, we were able to eliminate those issues in terms of material defect, because a lot of these things are created by humans. So that's the power of automation. Now we also use RFID 2D barcode and 1D barcode for our traceability. All of our materials, our tools, our machines are being tracked. So every movement, all of this information are tracked or extracted to our server. This is big data. Now, once we are connected, our machines are connected, systems are integrated, our factories are now online. The next is about developing the applications that talk to each other, especially for quality. Now for us, we have material validation. This is an automated process. When it checks the right material, like for us, we're using a lot of gold bars. It's very expensive, right? Epoxy, there's some mold compound, and making sure that we are using the right material for a specific product so that we will avoid any quality incident. Now we also place per unit. Remember, we are producing over 1 billion units. We have to trace each one of them. It's either we mark them on the package or we collect data. So we collect data from the wafer. We map it to where it goes as a substrate, coordinates, and if these are multi-die, you know, your cell phones or your smart watches already have a very small space. So you're using several IC within the IC, this multi-die. And we track this. And all of this information coming from these stations, we put into a centralized database. We cook it. Cook means we create something out of it for our customers to be able to access it. At the same time, for our internal customers, these are our engineers, use this data to improve our process. Okay? Still there? Good. Now, semiconductor electronics create a lot of inspection, right? Validation or some manual inspection by operators. So for us, all of our inspection tools, or most of our inspection tools, are connected to our backbone and connect to our centralized server for our connectivity. With this, we can be able to utilize a statistical process control to be able to feed feedback to the station if the sampling, if the monitors are okay or not. If not, this machine will stop. You don't need human to do that. Okay? Imagine we have 10,000 people, you're doing it manually, it will kill you. Okay? Alright, so moving on, so we have those deployed applications in the floor. The next thing is about how do we add intelligence. We collect data, as I mentioned, from all of this equipment, from all these monitors, inspections, from all of these process stations, and we centralize it to big data, and we can be able to create downtime analytics. What is the downtime? What is the problem? The utilization, if the equipments are utilized, taking note our equipments are very expensive. So every second counts. We also look at the defects or the yield, making sure that we are producing quality products. And we also measure our on-time delivery so that once we commit to our customers, we deliver it on time. Okay? Now, since we are tracking the unit level, we also create an analyzer so that if there's a problem or quality on the unit or the product, we can be able to simplify the problem solving or failure analysis. It gives you a way to look at operations, the materials being utilized, the substrate, the wafer, and even on other parameters. For example, if you have quality issues with one specific customer, this is specific material, we have to just type that material and then go show all the things that were processed from the materials. So we can be able to properly scope it out. So we open this up with our customers. This is a new one that we deployed this year. Now we also build advanced process control. so that our equipments are empowered to think for themselves. The good thing here is we build the rules based on the parameters set by our engineers. For example, if there's a consecutive alarm or there's some critical defects, then this machine will automatically stop. Okay, you don't need somebody to monitor it, or you will hire a lot of quality inspector in the line, but this system will be able to solve that. So auto inhibit means it will stop it automatically. So there is some traffic lights. Okay, moving forward. Now we talk about that in terms of about the focus in the factory. It's all about the quality, productivity, speed, cost, delivery. And with that, we were able to build our smart manufacturing blocks for Amcor. Now we extend this beyond doing that, meaning to say we have to go beyond the factory-centric and move on to our customer-centric. Our customers would like to have visibility of their products on our factories. They have the flexibility so that they can be able to study their capacity, their performance, the equipment. They can control it when they want to ship it. And also integrated their systems. So our system in the factory is also integrated with their system. There's connectivity between the supply chain. Okay? Now I give you one by one for B2B or business to business. We have all our factories having the same framework, the same platform, so that we have one-stop shop for our customers. We also integrated real-time operations management and engineering integration so that our customers are empowered to create their own reports. How much shipment did I make for the week? What are the problems being encountered for the week? With that capability, right, it's good, right? The other thing is we also give them power for analytics. So we build them analytics to be able to look at some behavior within their performance. Any patterns, any abnormal. So with this, you can be able to see it real time. Not tomorrow, but today. If I'm the customer now, I've ordered something at Amcor, I will look at the product that I ordered, and I will see it, type that product, I can see it. Where is it on the station? Right? Is it somewhere there? When will it come out? So they have that kind of visibility. Moving on, so we don't stop there. We build the smart manufacturing blocks, right? We go beyond it to be able to get to the value chain. Now there are next generation technology that we are not doing in Amcor. Okay, this is the funnel, looking at the mature technologies. So we already have this cloud, data analytics, big data, and we're doing a lot of pilots or proven pilots in terms of augmented reality, robotics process automation, automated data entry. And on our horizon, we're currently working with various stakeholders. We're now moving on to blockchain. AI will come in terms of machine learning, but it takes a lot of time to create that. Okay? I'll talk about our proven pilot because we are not using it 2019. And we have a Microsoft HoloLens. This replaces the physical interface of the monitor. Our engineers or our supervisors can now walk freely using that and doing some kind of setup. Let's look at the video. So you can now look at it, just looking at the machine, they can change it. They can do setup. Imagine that's our supervisor or technician doing some PM maintenance and without even looking at the machine. So imagine this, it will now improve the efficiency of the line, right? The other one is now we have proven pilots for robotic process automation. What it does is it automates the repetitive tasks. For example, you have a planning, people doing a lot of Excel sheet to website, to database, open to email. Robotic process automation is doing that. The good thing about this is it does not complain. It is running 24/7, and it does not charge overtime, correct? So we have 4 robots running now. For this one, it's a real production robot running in our factory, doing those automated steps. Okay, now some of our customers are doing their ordering through emails, through some files, through some FTP. So we're using the Astera to convert all those files going to our structured databases and put that to our system. Imagine we have 300 planners in our 4 Philippines doing multiple like this. Now with this capability, we're not able to automate that as well. So simplify it. Okay. We have a lot of challenges. These are my challenges actually because I'm responsible for it. Our challenges are, do we have the right equipment, or our current equipments are capable? Are the people also evolving? And how do you integrate it to the current infrastructure? And lastly, the biggest part is, how do I justify my capex? So let me tell you how I did it for Amcor. In terms of machine capability, we focus first on those machines that are capable. Those are not capable means those are running on the DOS operating system. You cannot connect that, okay? So focus first, finish it, and you get the value out of it. The second is, we have to migrate all our legacy systems. 2 years ago, I made a mandate, no more development on legacy system. Every development should move on to the roadmap platform. I stopped it because it creates a lot of people to maintain it. And of course, so Kevin is the expert for this. We add security hardening, a lot of firewalls, a lot of VPN, a lot of SSL, and we're making sure that our factories are safe. Now, people, right? People is the bottleneck for every organization, right? Now, what we did is, of course, change management is a process. But what we did is we tell good stories to our executive town halls. We monitor compliance and usage. No engineer can go override the system. Whoever override it, we're gonna terminate it. Okay? I killed all the systems to force the people to use the new one. If you use the old and new, then it will not work. At the same time, we involve people. We involve our line leaders to be part of our strategic planning. And for justifying CapEx, of course, you have to look at where's the biggest problem is, justify that you need it. For example, there's a quality problem on the station, and you have to justify it to making sure that you get the returns. But the biggest thing is about, once we enable the utilization analytics, we were able to achieve a minimum of 10% capacity improvement. That's big, that's millions of dollars. Now, I was able to reduce or do some CapEx avoidance. Instead of buying equipment, improve the factory. Now, just to end up, my key takeaways for this one, we have to have a strong IT. IT is the neighbor of business. IT is a competitive advantage. Now, without a strong IT, then it's very hard to implement smart manufacturing. Start small. Don't move the big ship. Start local. Make it robust and repeatable. At the same time, once you deploy it, of course, you have to do continuous improvement. People. We have to share the vision to our people. What is it in for them, right? So we have to share that, making sure they are with us. And everyone of the company is with that kind of vision. And of course, what we did, especially for me, is to be able to develop the right architecture based on the business processes. Okay? In our other factories, we develop a different one, but ensuring it should be cohesive with what we do in the Philippines. And lastly, we have to get a significant value to practical solutions. Meaning to say that don't just buy things because it's good, but you have to get the best one. So I'm doing some article on that one, so you can follow me on LinkedIn, because I'll be explaining all those aspects when we did that kind of highest value with practical solutions. So with that, Thank you for listening. I hope you get some